This is the first coding class on Cortex M4. Here I'm using TM4C123CA6PM. This is a TIVA microcontroller used for Cortex M4. Port that is used to read or write to the pin. Port dir is used to make the pin either as input or output. Port den is used to make the pin as digital and not analog. Here we are not using analog functions or not using any analog device, so it is using as digital, but actually we are not using all those I2C UART, SPI. This is digital function in this code because it is a very simple code, as it is a beginning. This is used. This is a register that makes to use the floating point unit by this coprocessor in case you're using float or double in your codes. So the system has floating point units, so and this register make it coprocessor to use it. So I'm coming to the main function. It is very simple code. RCGC GPIO is a 32-bit register and is used to provide clock source to any of the ports you want to use in your code. So this 20 represents if we have to write 20, it should be 1 here. So this 0 represent this, and this 2 represent this. Let me see something. Whether it can detect the pointer. Can detect the pointer. This 0 represent this, and this 2 is represented by this. So this bit 0, bit 1, bit 2, bit 3, bit 4, bit 5. This bit represents a port in these sections, in this case, because this RCGC GPIO says provide a clock source to a port. So it represents a port 1, port 2, port 3, port 4, port A, port B, port C, port D, port E, port F. That's why I'm choosing here port F. I write 0x to 0 because this 10 means 2, so that's why it is written like that. And this is port A, port B, port D, port E, port D, E, F. That's why. So it is port F. Okay, this dir means dir is used to set the pin as either input or output, but here I'm setting it as output. So 0 means right. So here this one is pin bit 0, bit 1, bit 2, bit 3. That means pin 0, pin 1, pin 2, pin 3. So I'm choosing the pin 1, 2, 3 as output pin. Okay, I'm making it the pin as digital, and you may be thinking why I want 0x 0e. Okay, why I write 0x 0e instead of any other number. Write 0x, right, 0x67, 0x90. Okay, I'm not writing any one of this, but I'm writing 0x 0e because I'm making it digitals. I have already chosen this pin, so I only need to make digital on this pin. In order to make it set, I have to write 1110, right? Because I need only this pin 1, 2, 3. That means E0. E. So I'm writing E here, and here I don't need to set anything, so I'm just writing 0 here. Okay. Because I'm choosing only pin 1, 2 and 3. So in order to set this, I have to write 111 here. That means I have to write 0, right? So it becomes the same. So that's why 0x0. So this is the while. This is the main area. For that is used to supply the data to the particular pin of the port you have chosen. So I'm setting it 0x 0e because I'm not writing any other number like 0x 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 like that, 0x 0b, etc. Because I need to set only this. I have chosen only this pin, right? So I need to set only this pin. If I need to set only this pin, then I have to write 0, right? That's why I wrote 0x0. Then I will give some delay. I'm giving some delay because this it will blink one time, but it will blink very fast. So in order to make it blink slowly, I'm making it I'm making it little slower. Here I'm not giving any data, and then as I have told, it will blink very fast, and then here I'm not giving any data, I'm just writing 0. That means I'm not giving any data, so it will blink on here, it will not blink here. It will be on, it will be off, it will be on, it will be off. If I'm not giving any delay, okay, if I'm not giving any delay, then it will blink very fast. Okay, this will be on and off, but it will be so fast that you won't be able to see it. That's why I'm giving some delay, 500 milliseconds, so that it blink very little slower, blink and then sometime and then blink. Otherwise it will blink very fast, blink and you won't be able to notice. That's why. So it will toggle on and off, okay. And then I'm writing delay function. I'm taking two variables. This is the first outer for loop. This will be inner for loop. So this will loop for 3180 times, and this will first it will execute this one time only, and this one will execute 3180 times, and it will execute this again, and then it will execute 3180 times. Here n means you are giving 500, so it will execute, this one will execute one time, and this one will execute 3180 times, until this one execute 500 times. And so total times it will be 500 into 3180, whatever you get is put here and make millisecond delay. And the last function, this one is not so important. Okay, this one is this note. This CPACR is a register of the system that makes the on-code procedure to use the floating point units, and it requires another code procedure to use that floating point unit, and this F is used to set two coprocessor 10 and 11 that is required by the ARM to use that floating point unit. That's all. So this is for today's class. Thank you all.